Okay, last one, and this is going to be pretty quick. 9 equals 5x minus 7x squared. Part A, we're supposed to see if this opens upward or downward. So the first thing that we need to look at is this in standard form? But there's another problem. There aren't two variables here. There isn't an x and a y. So it's not really possible to tell whether this parabola opens upward or downward because we only have one variable. We're trying to make, we graph x on one number line and we graph y on another number line. So basically we've eliminated this other number line here, making it only possible to graph along here. So we can find where x is equal, the x value that will make our expression equal to 0, but we can't really say anything about a parabola because we don't have a parabola. Parabola needs two coordinates, an x and a y. So for this one, we actually don't have a parabola. However, you could graph a parabola and then find the zeros. You could graph, you could put this in standard form. Let's put this in standard form now. 0 is equal to negative 7x squared plus 5x minus 9. Subtracting 9 from both sides to get 0 by itself and everything else on the other side. Descending order of powers. But we could also add 7x squared and subtract 5x, and what that would give us is 0 on the other side, but let's just put 0 on this side. Positive 7x squared minus 5x plus 9. This is upward opening if this were y equals, and this is downward opening, so we can't really say whether it's upward or downward opening. So if we don't have a parabola, we can't really say anything about it. Same thing with the vertex. This has a certain vertex and this has the opposite of that vertex. So again, we don't have a parabola and we're not going to have a vertex. For part C though, we can calculate the discriminant. This discriminant is b squared minus 4ac. And let me put d equals. So let me do this one with the with this black equation right here, and I get a is negative 7, b is negative 5, and c is negative 9. So if I substitute that in, b is negative 5. If I square that, subtract 4 times negative 7 times negative 9, I get that my discriminant is negative 227. These will all combine to make a negative. However, if I use this gray one, let's look at what actually happens here. So I get 0, or excuse me, my discriminant is I need to find A, B, and C. A, B, and C. A is 7, B is negative 5, and C is 9. So I shouldn't end up with a negative on both of those. Sorry, this should have been a positive 5, and this should have been a positive 5 over here. My discriminant is b squared minus 4ac. D equals negative 5 squared, for real this time, this is a negative 5, minus, it didn't actually make a difference in the calculation, by the way. When I square that, that's going to go away. It would have made a difference in the quadratic formula, but not in the actual equation. A is 7, and C is 9. Now this is still negative, and this is still going to be positive, so nothing's really changed. I still get negative 227. So the math still works out. The math works no matter which way we interpret it. So that's kind of nice because either way, in part D, we end up with our determinant, our discriminant being less than 0, which in turn means that we have no zeros. If it had been positive, if our discriminant had been positive, and it is possible to have a situation like this and have a solution, if our discriminant had been positive, then these would have both given us the same exact solution. It would have worked out the same way either way. Let's finish this off though. We can't really answer this. We can't really say if we don't have any zeros whether they're rational or irrational. And part F, we have no real solutions. We do have two imaginary solutions, but you'll go into that more in Algebra 2. No real solutions. And that's it for this homework.